Now we'd like to look at the null client configuration. A null client compares somewhat to a smart host configuration in that most of the handling of mail is handled by a different system or another system. In contrast to the smart host configuration, which relies upon a remote system for relaying and also does local relaying of messages for domains that are handled, null clients don't actually receive messages. Null clients simply send messages. So the ideal scenario to implement a null client would be, rather than from the enterprise box out to the DMZ, which is the professional box, but from the professional box to the enterprise box. Ideally, the message flow should be as follows: from the internet into your DMZ into your backbone, or let's specify this as corporate backbone. And in our model, the DMZ contains the box that we're currently on, Linux CBT work 1. So let's just specify Linux CBT work 1 dot for the domain. And the backbone is Linux CBT SUSE serve 1 dot, which is the enterprise box. So from any internet host to the DMZ to the corporate backbone, the DMZ system doesn't, or usually doesn't, need to actually receive messages. What it does need to be able to do is to forward messages, to relay messages, any and all messages, messages to abuse, spam, and so on. So let's go about configuring the null host to show you how it works. Only a few changes need to be made for our system to function in this way, but it will need to know how to relay messages into the destination system. We're going to use the domain linuxcbt.internal as our model. Let's say, for example, messages will come off the internet to a domain called linuxcbt.internal, but we don't want to handle it locally. We want to relay it to the internal system. By executing a dig against linuxcbt.internal for the MX record, it returns that the MX handler, or the mail exchanger, is Linux CBT SUSE serve 1. So by virtue of the DNS configuration that's in place, our DMZ system, the Linux CBT work 1 box, will use DNS to resolve the MX changer and relay the messages inward. We could set up a transport map to avoid DNS lookups altogether, so that messages come into the workstation or to the SUSE professional box, perhaps get scanned, filtered, and then forwarded directly without any DNS lookups to the SUSE Enterprise box. But that's up to you how you'd like to implement it. Either way, as long as it knows how to get to the internal system. Let's modify our main.cf file, since that's where most directives are changed. A few things we want to look at. We want to look at the my destination parameter, and we want to turn off the way it's currently configured. So let's get everything on one line. This is what we've done thus far. We'll now set my destination simply equal to nothing. That can be specified as follows, and this simply means we're not handling any local domains. But we're not finished. We should also make changes to the local underscore transport directive, and if it doesn't exist, we'll need to create it. Keep searching for local underscore transport, because we don't want our system to receive messages locally. Now you see, we're stuck in a loop here indicating that this particular variable is undefined. So towards the end of the document, we'll define, and we'll simply say added to enable null client support. And what we'll do here is simply specify that local transport be equal to error. And the error is followed by a message. We'll simply say local mail is disabled. Now, if you recall the transport section where we define the left-hand side followed by a transport and then followed by the actual path, this is a similar syntax. The error is the actual transport, and then this is the message rather than the next hop. So this is the same syntax that's specified when defining items or entries in the transport file. Left-hand side, which is what we match, followed by transport, followed by next hop. So local underscore transport will be disabled, and this is what needs to be configured in the main.cf file. So two things have occurred. We've set my destination to be equal to nothing, so that we're not handling any domains, including no messages to the local host, no messages to the fully qualified domain name, and no messages to any other domains. And we've also turned off local underscore transport. Let's save the changes, but before we reload postfix, we should update the master.cf file. What we should do in the master.cf file is disable the local transport. Now again, as I've mentioned, master.cf is responsible for the various transports. It specifies all the transports that postfix knows about, and it's also extensible. So in the event that you find third-party transports that are postfix compatible, you can include them in master.cf, and postfix will execute them, providing they understand postfix's lingo. Now the local transport is specified here, and it should simply be commented. This is used for local delivery, the local transport. You can also indicate that it was commented or disabled by a given user on a certain date. So we'll simply say disabled by Dino with the date of today to illustrate null client support. Now, null client support can also work in conjunction with the smart host configuration. If we grep relay host from main.cf, it's currently undefined. What will return are the default settings, because we entered the relay host, or we defined the relay host on the SUSE Enterprise box to relay through the DMZ box. Our DMZ box, Linux CBT Work 1, does not currently have a smart host defined, but you could use them in concert. So for example, you could determine by defining the null client configuration that the system will not receive messages, and it should also use a fixed smart host, whether by IP address or by name or by lookups. So you can use them in concert or not. It's entirely up to you. If you don't use a smart host, postfix in the DMZ configured as a null client or anywhere configured as a null client will still attempt to resolve the mail exchanger for a given domain as its default is. So when a message is sent inbound destined to a domain such as linuxcbt.internal or any other domain, postfix will not receive the message locally because my destination is undefined and local mailing has been disabled, but it will perform an MX lookup to determine who the MX or mail exchanger is for the domain. So if you'd like to skip that step to speed up the process of messages flowing in through your system, you should simply define a smart host in concert with your null client configuration. Super. Now let's execute a postfix reload. We'll examine var log mail, since we have disabled quite a few things, to ensure that nothing's blown up and nothing has. We still have the recent message, which was routed outbound to linuxcomputerbasedtraining.com, and the new entries, which indicate that the postfix system has been reloaded. Now to test this configuration, we should simply attempt to send a message to a user that would typically be handled locally. Prior, our configuration handled a few domains, including linuxcbt.external, linuxcomputerbasedtraining.internal, linuxcomputerbasedtraining.external, and so on. Now those messages destined to those domains should be rerouted and provisioned for on the SUSE Enterprise box. But before doing so, let's simply attempt to send a message. So we'll launch mutt, and we'll send a message. Let's delete these messages that are here. We'll send a message to root at linuxcbt SUSE serve1.linuxcbt.internal. We'll send it directly to the system that's located in shell number 1. We'll say testing null client config. We'll skip the body part and we'll send the message. Notice no bounce. Let's quit mutt and examine what's transpired via our logs. As you can see, the message has been relayed to Linux CBT SUSE Serve 1 as expected. In under a second, its status is sent with 250 codes being returned, a QID, and so on. So in the left window, if we simply execute mut, we'll see the message, and there it is, testing null client config. Nothing fabulous about that thus far, no surprises. However, what about for other domains that we were once considered the final destination for? Well, in order for this to work, we'll need to, of course, have either the transport maps defined to send the messages into Linux CBT SUSE Serve 1 or proper DNS configuration. Now, currently we have another domain called linuxcbt.external. We can dig it to query the MX record which points to .72. If we launch mut again and attempt to send a message to root at linuxcbt.external, DNS claims that we're to handle this message. So let's say testing null client. DNS claims that we're the actual mail exchanger for this particular domain. But guess what? There's no message. It hasn't shown up yet. So let's tail var log mail to see where the message has gone. Again, by examining the queue, you'll see that the message was removed from root to root at linuxcbt.external, status equals bounce because local mailing has been disabled. Our system is now a null client. It won't relay the message, so it simply bounce it, and this message will end up in oblivion. Or it may bounce indefinitely, which we should have a provision for. But once it bounces, it usually disappears. Mail queue shows that it's empty. So we're truly set up as a null client because we're actually not routing it to our local system. If DNS were properly configured with Linux CBT SUSE Serve 1 as a handler, the message would be routed to that system. Our system's now actually set up as a null client. It's not going to receive any local messages. It simply relays messages. It relies upon DNS and or transport tables for routing messages. This is how you set up a null client. You disable local transports, both in main.cf. You send an error. You also disable local the local delivery agent in the master.cf file, and that ensures that you can't receive any local messages. You also turn off all the domains that were routed to my destination. That ensures that you can't receive messages locally. You can alternatively define a smart host, which will speed up the process of delivery and resolution because the next host or the next hop will perform that for you, and define entries in the transport file to make the process work much smoother. But again, a null client differs in that it doesn't receive messages, and there may be valid reasons for such a configuration. You may have systems that are in a zone, such as the DMZ, that really don't need to store local messages. They simply need to forward the messages to an internal corporate system for review there and for centralization of the messages. So that's how you configure a null client. Any message that goes through the system will not be stored locally. The postfix instance will attempt to forward the message onto the destination either via DNS, transport maps, and so on.